and welcome to another episode of FooBar. Today I want to talk about event-driven applications. I have talked about event-rich quite a lot in this channel, so if you have not watched those videos, I recommend you to check the playlist and leave you linked. But today I want to talk about a more theoretical part about designing event-driven applications, because event-rich is great to implement those event-driven applications, but if you don't know how to design them, then you have to start somewhere. So, if you know, event-driven applications sometimes are called as choreographed applications. And that means that there is no central place where all the logic of the application is. So if we look at orchestrated applications, the ones that we are using, for example, step functions to implement, there is usually all the kind of state management and flow of the application inside the state machine in that case. When we work with event-driven applications, nobody knows how the whole flow is. And that's a challenge because our brain is very well designed to create one step after another one. But in here, the services are like dancers. They just listen to the events and do something about it. And that's a challenge because how we document those dancers, how we make sure that we know what is going on all the time, how we extend these applications after we implement something. So in this video, I want to show you how you design these applications. I want to show you a method to design these applications. I want to show you a method that you can then use to extend these applications, add new functionality, and always know what is going on in your applications. Also, I want to show you how to handle errors and edge cases, and in following videos, I will show you more tricks on event bridge. Now that you know how to implement this, design these applications correctly, event bridge will be even clearer for you. So in this video, I want to show you how to design one application, and I will not go into the full application. I want to show you one use case in that application so you can get the idea on how to do it. So let's start talking a little bit on the application that we want to model and design. Imagine that you are already running some kind of company and you have some of these microservices in place that I'm going to talk about. And now you want to start an e-commerce where you are going to sell some of your products. So you may have some microservices in place, like the payment service. For any reason, you already develop it and you have some connection with a third party, maybe Stripe or something like that is handling your payments. You don't need to worry about that. You might already have some customer microservice. You already have a database where you handle all your customer information and you have a way to add, remove, and all that with your customers. You may have an inventory microservice where all your products are stored and you can keep track of how many products you have of each. You might have some third party that is helping you out with the delivery and you might want to integrate to them. So that's a simple, very lean microservice to build. So the two new parts here are the order microservice, that is like the backend of your e-commerce, the one that will handle to make an order, to cancel an order, to be the status on an order, and then the web store itself. In this video, I will not talk about the web store. This is not a front-end video. This is a back-end video. We'll be talking about event-driven applications, so we'll focus on that order. And at the end of the day, you will see that this is more or less how the microservices will talk, and we will see how we can implement the event-driven application based in this diagram. So this is the first step for you when you are starting to design an application. Identify all the microservices that are going to talk to each other, and then try to think how the relationships are going in a broad way. You will figure out new relationships and new connections as you go through. So don't stretch too much, but you know that the order will call the payment for paying, and you will call the inventory to check if the inventory is available, and so on and so forth. So that's something you know. So in this example, we will focus in one use case. I cannot show you everything. It will take me forever to record this video, but I want to show you one use case. And this use case is when the customer wants to order a new product. And for the simplicity of this demo, the customer will order one product and one customer, one product. So very, very simple, just for you to understand how things go. Then you can extend this whatever you want. So now you might be wondering, okay, where to start? I know my microservices. I know more or less how they connect. Well, that's great. That's the first step. You have a general idea of what your use case is. So in the case of ordering something, you know that creating an order implies taking the product out from the inventory. You know that it requires the customer to pay for that order. You want to deliver it. And that's more or less the big parts of your flow. And that's where you're going to start. You're going to start there, and from there you're going to get in more granular things. One important thing to have in mind is what is these actions going to do? First, they are going to input an event. So an event looks like a customer has been created, a payment has been made. It's like something happened. Like when mom shouts in the kitchen, food is ready, that's an event. A command will be like, come to eat, you come to eat. But in this case, mom is event driven, so she will shout, food is ready. And whoever listens to that, that's good. And that's the input. That's great. Food is ready. A payment was made. A customer was created. An order has been made. Then the internal, what happened? In the case of mom, food is ready. The event inputs my ears. I'm very hungry. I stand up and I run to the table. In the case of a service, it does something. A payment was made. Well, what happens after the payment is made? Maybe the delivery starts, or a customer has been created. Maybe we send an email to confirm or to welcome. And then what is the output? And the output here is what kind of events it produces. It's an output event. Maybe it's an action that is done in that service. So for example, in the case of mom, food is ready. I sit on the table, and the output event is Marcia sit on the table. In the case of payment was made, maybe the delivery started, and the output event is delivery started. So the output events can trigger a service. So one message, one service, that's very reasonable. Sometimes we can have parallelization. One message can trigger multiple services, and that's good. One, two, or many. And this is when it's getting trickier, because then your brain it's hard to keep track of everything. Or one message cannot trigger anybody. And this is done. This is great for extensibility. You just shout all your messages, and eventually when you want to make your app bigger, then you can do something with it. In the case of the food, I sat on a table. Maybe it doesn't trigger any message because nobody cares. But in the future, if I have a kid and mom sit on the table, me sit on the table to eat, that means that the kid will do something about it and I will not be able to sit. Something all parents can relate, never being able to sit. When we are talking about events, another thing you need to design here is how your events are going to be formed. There are mostly two ways of doing this. One is to provide as little information as possible, and another one is to provide as much information as possible. So when we provide as much information as possible, then it's great. We will say the order was this number, it was created by the customer, and all the information of the order and all the information that we can put there. This is great. No other service might need to go to any other service to get more information. They make the services very decoupled, and everything can scale automatically. Here we have a problem with eventual consistency, because maybe the order changed since we output the message or we process the message. So we might be working with old data, but that's life. And that's something you need to have in mind when you're working with this type of events. If your application needs to be more consistent, then you might need to go with the little information as possible. That will require that your new service, new action goes back and gets all the information right in the time of processing the event. This has a problem that then if we have a big scale of events and we have many events that get, like many services that get triggered by one event, or they all might need similar information, they will bombard this service that contains that information with messages to try to get the extended information. So in the case of what you're seeing in screen, everybody is asking for information on the order 123. So now the order service is like, I I need more resources to process all this. And this is not very decoupled. This can produce errors in scaling, but this provides consistency because then all the messages are kind of stuck until this other microservice responds. So in a way, you need to choose your battles and what is the best option for you. For this demo, the messages are going to be fat, big, explicit messages with all the descriptions, everything that we need, because we can. So we are going to have one big event that is going around everywhere and it will be sending information around. So now the next question is, how you design these architectures? We might be tempted to grab a piece of paper, an iPad, and start drawing and writing different microservices and start connecting them together. But as soon as we hit some level of complexity, this becomes impossible to read, impossible to scale, and these kind of diagrams are great for state machines, but not so great for event-driven applications. So, for event-driven applications, the best way to document and design this is using a table. Yes, a table. So give me a like if it's the first time you ever hear that the best way to design event-driven applications is by using a table. And if not, give me a comment and tell me how successful you were using this method. So in this table, you're going to input all the events and how they flow. We will have actually two tables, one for event flows for each use case, so there will be a lot of tables, but per use case, and then one table for all the events, so you can document the attributes and so on. So open your favorite spreadsheet and create a table that looks like this. Put the name of the table to be like the use case, like in this case, or create an order, and here you will have each rows represent an execution, like an action has been taken, and then each of the columns will have different values. So API is when the call comes from an API. So this is a synchronous call, like for example, the first invocation in the flow. Then we have the input events, what is the event that triggers this. Then we have the service name, like the microservice name, the action, what is the method that it's executing, and then the output event. So we will see this in more detail as we go through the demo. So, how you start populating this table? That's a great question. First, a disclaimer. You need to know that in any design process, and more in a process that you're not familiar, that you have not done before, you need to iterate. So what I'm going to show you today is the result of iteration and work. So you will see that it's very easy and flow and la 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 la, but I have done my homework. This is something I did some time ago and I found the flow. So have that in mind when you're designing your applications. You will not achieve the perfect result on the first time you sit down and do this. Maybe after you do it for a while, it will be easier, but the first time definitely it will take you some iteration. So let's go back to the question, how you populate that table. Well, you will start from the beginning. Let's go back to our rough vision of how the flow is going to be. We want to create an order, we want to remove the element from the inventory, we want to make a payment, and we want to start the delivery. Great, that's our beginning. So that's where we are going to start with. Another thing here is to start deciding how big your methods are, like how simpler they are, if they are doing one activity or multiple activities. You might already have some microservices that have some of these methods. So that's something you might need to have in mind. But for example, in the case of the order microservice, you might need to design them all from scratch. So that's something to have in mind. And when you are putting your lines, then you will need to have that in mind. In our demo, things are going to do one thing and one thing only. That's a good practice when you're working with function as a service, when you're working with Lambda, when you're working with serverless, then it's easier to test, easy to extend, and blah, 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 blah. So let's start by creating an order. The first thing that happens is that our web app will send an API call that says an order has been created. So what do? We want to save that order in the database, and then we want to send an event out. And that event is the type of the order created, and it will have the order ID. That's the only thing that happened. And believe me, this is simple, but this is great. This is so simple to test if you do it this way. So now we go to our second table, the one that we have designed, and this is the events table where we are going to input all the details of the events. This one you can have one per use case, or you can have one for all the events that are in your application because you will share events around, so it doesn't matter. So here we put the event name order created, and this is very important. What are the attributes that are inside that, so you know what you can expect. So in this case, the customer ID and the product ID, this is coming from the API in the call, and the order ID is the one that we create when we save that order in the database. This is created by the order service in the create order action. And that's it. Now we know what is inside that event, so if we need to reutilize it later, we know what it has inside, and you don't need to dig for that information. Now, let's go back to our rough kind of idea again. First step is remove the element from the inventory. So that's the first step in mashing when we are kind of doing our order create. But if we remove the item from the inventory, that means that the customer have paid for it, and it hadn't because we have not processed the payment. So what happens if the customer doesn't have money? Then we need to put the item back. So one better way to do this is to reserve the item. To mark the item as reserved, we remove that item from the inventory in a way, in a kind of light way. So basically, we have one column in our table that says that the item is reserved, and nobody can buy that item while the item is on hold. So we can do the processing, the payment, and everything, and the item is saved for the customer. So this method is the item reserve method that is triggered by the order create. And this is in the inventory microservice. Maybe this is something you need to implement, that it was not there for you, so you might need to implement it. And this, what it does, it goes to the items table and it updates that it has something to reserve, and it produced two events. One that is the item reserve, and then the item not available. Item not available is an error event, and we will talk about that in a moment. So now we go back to our event table and we add the new event type to that table, the item reserve, and it doesn't have much. It has the same attributes, so customer ID, product ID, order ID. That's good, it's been generated by the inventory microservice and the reserve item. Now we need to decide what is the next event, the happy path or the error path. And it's important that you do both, but for our design purpose, we are continuing the happy flow, so you start grasping how this works, and we will look at the errors later on. So, what is our next step in our rough vision? Well, the order is created, we remove the element from the inventory, in this case we reserve it, so we might need to remove it later. Now we want to make the payment, and for the payment, what I need? Well, I need the product, how much the product cost, and I need the address of the customer so I can calculate the delivery fee. Do I have the address of the customer? No, I have the customer ID. Do I have the product information? No, I have the product ID. So the next step is to get that information. So here you can see how new kind of functionality, new things that my method needs to do start appearing, because we start asking these questions and we have not put one line of code yet. This is all thinking, and this is very cheap. Thinking is quite cheap. Coding is expensive. Thinking is quite cheap. So then we can see that the item reserve now will trigger the describe item, and the describe item will return all the information for the product, including the price. Basically, it does a read in the item database. Then we have now in our events that the attributes, the new event is the item describe, and the attributes has the price. Good. Perfect. Start getting the flow. Then the next thing is to get the product, the customer information. So we want to get the customer address so we can calculate the distance. And for that, we need to go to the customer microservice and describe the customer. And we do that with an input item describe. And here you can see that this is done linear. We could do it parallel, yes, but for the simplicity of this demo, I will do it linear. But definitely, the item reserve can trigger the describe item and the describe customer at the same time. That's fine. It could do it, but it's easier to do it linear. And now that we have the customer and we have the item information, we can estimate the delivery cost, and that's done by the address of the customer. Maybe we have the weight of the product. I don't know. All this information you need, and we estimate the delivery. Then we make the payment. Now we have the amount of money that the customer needs to pay, so we make the payment and we remove the item from the database. That's great. But what happens with errors? We left a lot of errors untouched in the past and nobody did anything. One important thing to have in mind is that when you have operations that have side effects, meaning that they save in a database, they alter the data somewhere, they call some third-party API, those operations need to be reverted. So when we have an error, we need to revert the operations that have side effects. So it's important to have in mind that when you're designing the error flow. So now we will look at an example of an error flow. In this case, we have that the payment failed. So we estimated the delivery, we reserved the item in the database, and then we make the payment and the payment failed. So what we need to do to revert this in our flow is to mark the item unreserved. We need to remove that item. We need to put it back in our inventory. And that's the only thing we need to do in this particular case because that's the only operation that has a side effect. The other operations are mostly reads and that's okay. We might also want to kind of mark the order as undelivered or something like that. So we could add one more step afterwards and that's okay. But you need to model the flow of the errors as well. So model first the happy path and then grab all the errors and make sure that you have a path for each error to be resolved and all the operations that have done side effects in the happy path can be reverted in the error path. And this is how you design event-driven applications. Just practice with this method, practice over and over again, and you will be fine. I will leave you the code for all this in the description box. You can get it and you can play around. It's an event-rich application that you can see how it works, so go ahead and check it out. But before we leave, I want to add one more thing that I think is very important for the event-driven applications, that is the extensibility. That's one of the best things of event-driven applications, how easy it is to add new functionality in this application. So imagine that in our e-commerce, now we have solved all the problem, it's out, it's in the public, people are using it, great. But we realized that maybe we should send an email to our customers when the payment failed or when the delivery started or in different places, so customers is aware what is going on, because now basically they buy something and suddenly a package appears on their house or maybe it doesn't. So if we want to send an email when anything happens, now we can basically trigger an action on different events. So if the item is not available, we can send an email. If the payment is made and successful, we can send an email. If the payment failed, we can send an email. And you see the point here. So basically, by just using these events in the trigger multiple actions, you can extend these applications so easily. So that's it. That's everything I wanted to share with you. This is a different video from the ones that I do normally, but I think this is something important that needs to be shared. This is something that we need to talk more about because event-driven applications are quite new and not everybody knows how to work with them or how to design them. Let me know in the comment what kind of other videos you would like to know about event-driven applications. It can be in the theoretical world or it can be in the event-rich where I want to make more content to help you to make these applications successful. So I see you in the next episode of FooBar. Ciao, ciao!